I want to talk today about ōpən. ōpən is Ciena's vision for the future. ōpən does have a very bad joke in it. It has been written by marketing people. ōpən stands for Optical and Packet Networks at Exponential Scale. I'm really sorry. It's what you let marketing people do when you work for companies. But ōpən is about the coming together of all the layers and how you bring together optical and packet networks, and most importantly, how on earth you cope with the scales that we were asking for in networks today. So what is ōpən? ōpən is three things. ōpən is scale. I could put up a load of charts about the fact that traffic is growing, bandwidth is getting bigger, more people are getting phones, but you're pretty much bored with that now, so you've seen it all before. Programmability. We heard today there is the big SDN thing. SDN in a data center is relatively well understood. People are quite sure of that, but what SDN means in the network, and especially between data centers, is a lot more of a more difficult question. There's lots more work still to be done there, but what it is going to be about is programmability. It's about the ability to change the network to react to external events rather than the sort of plan and build cycle that we have at the moment. And finally, apps. Oh, wouldn't everyone love to have an app store? Wouldn't you like to have that 30% that Apple take cream off the top of absolutely everything? I know everyone wants it, but we're not all going to be able to have it because we don't all employ shiny things. But network level apps, the ability to drive a network from external interfaces, be able to persuade your network to do things that you simply cannot do today, is really important, and it is coming. Now, whether you agree with this or not, we can sit there and we can have a debate, and that's the whole point of this conversation just before beer, is let's go and have a conversation about it. But this is coming. This is coming. This is, some guys, is going to affect every single person in this room. So, ōpən. Architecture. Come on, we haven't had enough architecture charts. We haven't done enough clouds. We need cloud pictures and stuff. So, bit on the left, this is about how aggregation networks work. Most of you, looking at the names, you've got residential users, you've got mobile users, you've got enterprise users. The interesting part about this network is it's all about connecting users to the content. The bit on the left, the bit in the middle. Content centers, it's your server farms, it's your data centers, it's where all the content lives, it's your BRAS, it's your content caches, it's where YouTube have dropped a server on you. The interesting thing about this part of the network is that the nodes are relatively static, that things tend, houses don't move, base stations don't move, and companies don't move very often. So you get this big fan in, it's a very strong tree-shaped network, it's about sweating the asset, it's about 20-to-1 ratios, it's about getting as many users as you can economically into the content. The other side of the network, the core, is actually the opposite. That in this part of the network, when you're joining the content center together, joining servers together, joining big fat pipes, this part of the network actually moves around really quickly at the moment. That suddenly, whichever cat video is #1 on YouTube at the moment, or in fact I suspect a resurgence of a Steve Ballmer video, that might be going back up to the top of the YouTube charts after today. But the content flow around, and this part of the network changes on a minute-by-minute basis. So whereas the network on the left is tree-shaped and the flows all kind of stack mucks and everything is about the same, the network on the right shifts around really, really fast. It's a big, fat flows, joining it together. And the one thing, to bring this full circle to where we started this morning, so first presentation this morning started to talk about remote peering. I don't know if Bill's still here. Bill's still here? Hi, Bill. You've made my point very clearly this morning, which is what, thank you, by the way, for doing it an entire day in advance, is that it is cheaper to not have routers everywhere. That was the point you were making. You were making the cost of the... And the same in this network is that if you put routers everywhere in this network, you are going to be more expensive than your competition. Because one of your competition is going to build a lean packet core. Get as many routers out of the network as possible, get all that cost out of the network as possible, make it simple, make it programmable, make it tractable as a solution so that you can apply software to this. We also heard about automation today, about automate the hell out of your network. So this is the section you have to automate if you want to save the most amount of money. We also heard today, hello, is it going to animate? Oh yes, come on. I really shouldn't do animation in charts. We also heard discussion today about SDN. What is SDN? Well, SDN and data centers, we understand. Our view is that there will still be control planes in the telco environment. In the carrier environments, control planes do some very, very useful things. This idea of completely making the boxes stupid is not going to work. That said, you can make a much simpler box today than your current 7 foot high, 3 feet wide, couple of $1 million router. There are a lot simpler ways to make boxes, and you can see this coming from all the vendors. What's interesting about this architecture of apps driving through operating systems to the network apps, which is what all you guys are interested in, driving down into the network so you can program the network, you kind of see this from most of the vendors at the moment. Interesting about Ciena is we already build this. We have this running, and you were asking some questions today. We also now have this in the network in some North American networks and in Japan as well. In fact, if you were talking today about where SDN is, go look at NTT. NTT is 5 years ahead of anywhere else. They are so far down this path of a programmable application network. So we have this, and it's now getting to the stage where the apps will run on your iPad. I noticed the fact that this room is completely full of Apple products. I have all these little glowing apples facing me at the moment, which is rather exciting. Run it on your iPad. This stuff is really, really simple. Imagine being able to swipe around your network. It'll be cool. It'll show off, but actually it's really important to understand that it's the API behind this. That is how you're going to drive your network further into the future. So, trying to wrap this up really quickly, because we're between you and beer, which is never a good place to be. Scale. I can draw hockey stick curves till the cows come home. You can go and do your research. What you've got to crack is making the bandwidth double and your cost not double as well. That is only going to come from a simpler network built out of cheaper boxes and more automation. That is the only way you're going to get scale. You're all in a competitive environment, lots of operators here. We're all being very nice to each other, and I noticed from the governor's presentation, we're all being very nice to each other here, but we're all competing with each other. You've got to differentiate. You've got to do something different. And how you do that? Well, that's a really interesting question. We'd love to help you. We have some ideas. You've got some ideas. But it's going to come down to software. And apps, again, how do you differentiate? But it's also how you run your network. There's a lot of very expensive ways and tools and layers and monitoring stuff and wow. We've got to get it simpler. So, strong ecosystem, but above all, this has all got to be open. If this is single vendor, if this is proprietary, it's not going to work. So it has to be open. So open is open. So final pitch, we're a sponsor. I get to do one slide saying, hey, Ciena. So Ciena, we're a network specialist. We only build network equipment. We build photons, we build packets. We do not build any of the rest of that stuff. Therefore, we know what we're doing. And we're trying to take a slightly different view, simplify the network, stop spending money on routers, start spending money on boxes that actually move bits effectively. Thank you very much.
Thank you very much, Simon.
That's right. Any questions?
Any questions?
Ah, Neil. Neil, you always have a question.
I'm just wondering how these magical devices, let's call them magical devices,
Okay.
Understand BGP updates.
Yeah.
How do they do that?
They don't.
So, and then how do they decide how to route traffic?
So this is about the layer beneath the routers.
So you want to confuse a layer above by messing with a layer below. Is that the summary of the story?
No, because routers are very used to operating over point-to-point links. They're used to operating over to any networks because those are the two fundamental forwarding behaviours of Ethernet and leased lines, which routers have had in their DNA from the very beginning.
Yeah.
That is all we are providing.
But you said less routers.
Fewer routers, yes.
How?
How? By, I believe the number you gave me was that what's the ratio of transit traffic in your network?
Sorry, what's the ratio of?
Transit traffic in your network.
Transit traffic in our network?
Yeah.
To other ISPs?
No. Sorry, transit traffic through your P routers in the core. It's 75%?
Much lower than that.
Okay.
Topological optimization.
Yes.
Much lower than that.
So I mean, it's a great presentation, but it lacks two things. One, numbers and facts. So it says, we've got this nice swipey thing, swipe,
yep.
swipe, swipe, and the world is good.
Okay.
Where is there a bar chart that says, this is cheaper? Whereas an actual example, it's kind of like you're trying to sell me a car, and the picture is this beautiful Porsche, and you turn up and the reality is a clapped out Maestro.
Okay.
Sorry, it just irritates the hell out of me because
Okay.
I think Ciena have got some fantastic products. In fact, we've rolled many of them out and we've done some fantastic optical testing, and it irritates the hell out of me when you do a presentation like this and there's no numbers in it. You say it's going to be cheaper, be easier, it'll work better, and there's not a single number that says how.
Okay.
Does that feel unreasonable?
I have a ton of data and I have a whole lot of stuff. I felt that at the end of the day, the last thing you wanted was 101 cost candles and me arguing about 25, 30, 45% cost savings, which is what we can do.
Hands up in this room if you would not like 30% cost savings. Sorry, yes. I apologise. We'll get to that. So I think maybe we'll invite you back one day and you can show us some numbers.
I can very happy to give you numbers, Neil.
Okay, I think we're just about done.
Okay.
So thank you, Simon.
Okay.
Thank you again, Ciena, for sponsoring. It's a full sponsor. Just a few announcements to do before we wrap up. The doors at the end will be opening to optimize.
Your mic's not on.
Oh, sorry. Sorry, just a few announcements before we wrap up. The doors at the end will be opening to let you get faster access to the beer, but if you could just sort of like wait until they're open and stay in your seats, that would probably lead to smoother flow in both directions. So, one of the things that I do at the end of these meetings is just to thank everybody who's contributed to the meeting. In particular, sponsors, Ciena and Alternative as our gold sponsors, our silver sponsors, A10, ADVA, Cube, NLIX, and Data Centered, our bronze sponsors, Imtech and Infoblox, Amazon for doing our name badges, and Go Communications for the t-shirts, Bogons and Portfast for the webcast. We hit 70 eyeballs on the webcast today, so it's not just the people in the room. And obviously, not to forget hardware.com, who are paying for the beer that you were about to receive. So I'd like to thank the program committee for putting a packed program together today. It's slightly more material than we usually manage. I hope you enjoyed it all. I thought there was some great talks, and obviously all our speakers for contributing. They come here on their own time and expense. Special thank you to thank you to all our volunteers, but special thank you to Mike for making sure that the network did its thing today and debugged some of the building's network in the process, and also to Nat for all his help with the presentations and a whole bunch of other things. UKNOF27 registration is already open. The call for presentations is already open, so we have a whole bunch of things nailed down for Manchester, so please go ahead and register before you close your laptop. And Fergus, have you still got some Atlas probes to get rid of? Is Fergus still here? No. Okay, so Fergus has got, you got your Atlas probes from Fergus. So yeah, just a big thank you to everybody who supported the meeting and made it happen. And thanks everyone for coming. It was a great turnout. We'll see you all next time.